Hey everyone, we are going to be doing notes on gravity today, and it is going to be on page 17 in our interactive notebooks. So, what you need to do on your table of contents on page 17, we're going to put gravity, and then we go to page 17 in our notes. So 15 was magnetism, so if you forgot to write page 15 on that one, please do that. And then our next page is page 17. And then we set up our Cornell notes. So we have a line down the side, and two lines across, one up the side here. And then I'll put my name. And the date, this is a little off, but I think it was, no, that's not, I want to say it was 11/24? I don't think that's right. Whatever. And then what class period you have. So on the top, we'll have gravity. And our essential question is, what causes gravity? And, I mean, it's probably an oversimplified answer, but we're going to get to it. Our first word is gravity, so let's put that in here. So gravity, what is gravity? So gravity is a force. So it's a force of attraction. So a force that attracts all objects towards each other. And depends on mass. So, since you have mass and the Earth has mass, you guys are attracted to each other. You feel the pull of Earth just as much as the Earth feels a pull on you. But you're a lot smaller than the Earth. And so it feels like you're getting just pulled in, to the Earth. But you're actually pulling on Earth as well, which is kind of cool. And that's what we're actually going to get into, forces and how we get forces, or how forces work more than anything. So let's talk about force. So force is just a push or a pull on an object. So it's a push or pull on an object. And so gravity obviously is pulling us in toward the center of whatever mass that is next to us. So that's helpful. We just talked about magnetic force, and that's pulling you in a certain way, or not you, but magnets in a certain way. But let's talk about forces and the way those work. And in order to do that, we're going to talk about Newton's laws. Of motion. And in order to get motion, we need to apply a force. So the first law of motion is technically something called inertia. And that is going to state that things at rest stay at rest. And things in motion stay in motion. And there's a little caveat there that It's unless acted upon by an outside force. I got ahead of myself. So these things are true, these first two things, until it's acted upon by another force. So acted upon means like, you're applying a force. So something that's going to stay where it is until you apply a force. It's not going to move. Or it's going to stay in motion forever until another force is applied. So if I throw a ball across the room, it will go on forever until a force acts on it. Well, there's already forces acting on it because there's gravity pulling it down. There's air resistance slowing it down. That's a force in the opposite direction movement, so it's like friction. And so those things, if they weren't there, like if we're in outer space and I threw something, it'll go on forever unless there's another force of gravity or something, or if it runs into something. That's an outside force. So that's what inertia is saying, is that everything's going to keep doing what it's already doing unless you apply a force. So that's the first law. And then our second law of motion is actually an equation, but it's telling us what I was just saying up here. To move a mass, you need a force. And that equation, F equals ma. And obviously that's force, mass times acceleration. Is there only supposed to be one L in acceleration? I feel like I should know that. You know what? Doesn't matter, right? Oh, there is only one. I looked it up. Okay. At least I corrected myself, right? Okay. So, that's the second law. Basically saying, in order to move anything, you need a force. And there's the equation, which is kind of cool. So you can calculate how it's going to move if you apply a certain force to a mass, how fast it will accelerate. And then the last one, the third law of motion, this one you've probably heard about. Every action has an equal and opposite reaction. So if you've ever seen that Newton's cradle, the thing that there's like the balls on a string and then one comes out and it hits this one and this one pops up, and so this one's moving down and hits that, so this one is carrying the force of one ball, and then it's going to hit this ball with that same force, and so it's going to pop it up the same amount. Obviously, some energy is lost because of sound and air friction, whatever. But yeah, it's kind of just a conservation of energy sort of thing, where it's moving the force equally and opposite directions. Or if you push off of a wall or off of someone else with your roller skates, you're going to push away from each other, and then you're applying this force, so you'll move. It all kind of ties together. So these are the first, second, and third laws of motion. So write this down, and we'll go on to page 19.